Okay, in question 2 of Excel Lab 9, we're going to look at a chi-square test statistic, a chi-square test, where we want to determine if two things are dependent or not, or independent, right? In this example, you see a local news report that questions the hiring practice of an office in a rural southern town. So you construct this pivot table down below right here. These are the observed frequencies. Determine if discrimination against Black applicants is occurring. Now the question is, at 5% level of significance, does the data suggest discrimination against Black applicants occurs at this office? Now, this test doesn't tell you that discrimination is happening. What it does is it suggests there may be a dependency between race and status of applicant, whether they're hired or not hired. Okay, so this would be like step 1 in several steps to determine if discrimination is occurring. Now, the alternative hypothesis is that there's a dependency, right? Hired and race are dependent on each other. The null hypothesis is independent. Okay, so hired and race are independent in the null hypothesis. Now, in the observed frequency table, the data had 76 applicants who were hired and white. So that's that number right there, right? It also had 29 applicants who were white and not hired. And then it had 30 applicants who were Black and hired. So I got to change that to 30. And it had 27 applicants who were Black and not hired. Okay. Now I have to resum this column. So I'm going to use equal sum those two, and I get 106. Then I can drag this across the bottom, and I got 56 here. Then I need to sum the rows. Then drag that down. And then this, you can sum those two column totals. You can sum these two row totals, or you can sum these 4 values in here. And each time you'd get 162. So you get 162 for summing those 4 values. You get 162 if you were to sum the row totals, and you get 162 if you sum the column totals. Okay, we'll just sum the observed frequencies. 162. Okay. Now, the way this test works is we have expected frequencies. And the way the expected frequencies work, I'm going to go ahead and expand this out. Again, I'm doing this in the template Excel model I put together and uploaded to the lab, right? So now we got to calculate the expected frequencies. And the expected frequencies are found by taking the expected frequency of white and hired is found by taking the row total, the total number of white applicants, and multiplying that by total number of hired applicants. So we got the total amount of white applicants times the total amount of hired applicants. And when you multiply, remember that's the word and. And then we're going to divide that by the overall total. Yep. And we get an expected frequency of 68.7037, which is kind of close to 76, but not exact, right? The expected frequency of white and not hired is the total number of white applicants times the total number of not hired applicants. We're going to divide that by 162. And we get 36.2963. Now that's kind of close to the 29. And then we're going to sum it. And if our expected frequencies are right, the sum of these two expected frequencies should be a 105. And sure enough, it's 105. Okay. Now the total number of hired and black applicants is the total number of black applicants times the total number of hired applicants divided by the overall total. And that equals something close to 30, right? Not exact, but close. The expected number of not hired and black applicants is the number of black applicants times number of not hired applicants divided by the total number of applicants. Again, we did this right if this adds up to 57, and it does, right? Those two add up to 57. Now, if we did this right, these expected frequencies of hired should add up to 106. And it does. Then last but not least, the not hired values, expected frequencies, should add up to 56. And they do. And the final thing we have to do is we have to sum 4 expected frequencies. Okay? And we get 162. Okay. So we have our observed frequency table finished, and we have our expected frequency table finished, right? And if the expected frequency, there's going to be a difference, right? There's going to be a difference between what we observe and what we expect due to a variety of different factors. Randomness of the data, right? We have a random sample here, right? So there's going to be a difference between this value and that value, this value and its corresponding value, this value and that value, its corresponding value, and this value and its corresponding value. There's going to be differences, right? The probability that this equals that, this equals that, this equals that, and this equals that, that probability is 0, right? So knowing that there's going to be a differences between our expected frequencies and observed frequencies, the question is whether those differences are significant, whether that collective difference is significant. If that collective difference is significant, then we would conclude that race and status of the applicant are dependent. If there's a collective difference and that collective difference is significant, if that collective difference is significant, then the variables are dependent. We're going to conclude that the variables are dependent, okay? And that's how that works, right? So down here is how you calculate the chi-square statistic. We have this 76, right? This 76 white and hired subtracted from the expected frequency. And the expected frequency is 68.7037, right? So what we're doing here is we're taking what we observe minus what we expect, and we're squaring that, right? So this numerator is the squared deviation from expected, and that's why we're using a chi-square statistic, right? And then the next one is the 29 not hired and white applicants minus the expected number of white and not hired applicants. And that is 36.2963. We need 4 decimal places. So, okay, there's 5. So that would be a 3 right there, right? Okay, and that's the next component, right? So this is the square deviation from expected for white not hired. And we square that, right? And then we have the next one, 30 minus. So this expected frequency, which is black and hired applicants, and its deviation from the expected, which is 37.2963. And again, we got to do 4 decimals, so that's a 3 right there, right? Okay. And then the final one is 27. This is the black and not hired applicants. And its expected frequency is 19.7037. And then we use 4 decimal places. I'm going to hit enter to make sure those are all good. So those are all good, right? So now we're going to calculate the chi-square statistic in Excel, right? What I'm going to do is, instead of copying this or doing this by hand, I'm going to do it over here in Excel. So let's do the chi-square statistic right here. Okay, so this right here is going to be the sum. I'll type this right now. Sum of these 4 values. I haven't done them yet, but I'm going to get there, right? So this is going to be 0 for now, right? Okay. So the first square deviation from expected is we have 76 observed, and we have 68.7037 expected. And we take that difference and then we square it, and then we divide it by expected frequency. And we get 0.77486. Let me round that to 2 decimal places. Now this is going to be quick. I'm going to make this really quick here. I'm going to pull that over here, and I'm going to pull it down here. Okay. So let's just look at what we got here. We have what we observe minus what we expect for white and not hired. We square that and we divide by our expected frequency, right? And then we have the observed frequency minus the expected frequency for the category black and hired. We square those deviations and we divide by what we expect. And then lastly, we have 27, the observed frequency, minus 19.7037, the expected frequency for the category black and not hired. We square those deviations from the mean, and then we divide by the expected frequency, right? So our chi-square statistic is 6.37077, right? Again, that should be 4 decimal places. Okay. Now, if there were no differences, so I'm going to say there's no differences, right? So this is 76. So if we observed 76 and the expected frequency was 76, and then suppose again we had expected 29 here and we observed 29, and suppose we expected 30 here and we had 27 here. Suppose we expected 27 here and we observed 27, right? So if these expected frequencies are identical to these observed frequencies, we have no differences between the observed and the expected, and our chi-square statistic would be 0 because our collective differences are 0. And we would conclude that white, black is independent of hired, not hired. So race would be independent of whether you're hired or not, right? Now, if we had expected 77.5, right, and we observed 76, or we expected 27.5 and observed 29, and then expected 31.5 call this 28.5. If we expected 28.5 and it was we actually observed 30, and then we expected 28.5, but we observed 27, we have small differences, right? Small differences and a small chi-square statistic. In the real world, we're going to have differences. We're not going to have zero as the differences. We're going to have small differences to big differences, right? So the question is, are these differences significant or not? So let's go back to what we actually expected, right? So with these expected frequencies and these observed frequencies, these are kind of like our deviations from expected, right? They're not zero, but they're not terribly large. The largest of the four is because 27 and 19 are almost 8 apart, and 27 is a small number, right? 19 is a small number. So our biggest squared difference relative to our expected is black and not hired. But the other ones are kind of small, right? And our chi-square statistic is 6.3708. Is that large enough to conclude that there are a difference? There's a difference in expected and observed. Is it large enough? That's the question. Now, to do that, we have to calculate the degrees of freedom. In this particular chi-square test, independence test, K is the number of rows and M is the number of columns. So we have 2 rows and 2 columns. So 2 minus 1 is 1, and 2 minus 1 is 1. 1 times 1 is 1. So I'll do 2 minus 1, 2 rows minus 1, times 2 columns minus 1. And we get 1, right? Now we got to calculate the p-value. We got to calculate the p-value that corresponds to this, right? So I'm going to pull up the chi-square stat distributions calculator. I'll squeeze this too. This is the only part we need now. So I got the stat distribution calculator here. I'm going to click on chi-square. Okay. And my degrees of freedom are 1. Right. And that's what chi-square looks like for degrees of freedom equal to 1. And my chi-square test statistic, if I put my chi-square test statistic into the chi-square value, I get a probability value of 0.011. Now I need it to 4 decimals for my problem here. I'm going to type it in anyway. 0.011. Okay. And then I'll refine it later. Okay, now I need my critical value for the test. So this is my significance level of the test. Let me double check that. The significance level is 5% right there, right? So I'm using 5% level of significance. So I'm going to change the p-value box here to 5 to represent the significance level. So this area here is my significance. So if the chi-square test statistic is under the blue area, the differences are significant. Again, the differences are significant if the chi-square test statistic is out here. The differences are insignificant if the chi-square test statistics is under the white area. But under the blue area, which is my significance level, right, 0.05, the test statistic, if it's out here, the differences are collectively significant, right? And my chi-square critical value is 3.838. And again, I'm just going to type it in there, and I'm going to verify it with Excel. 3.838. Okay, so now I'm going to redo the p-value. I need to find a probability value, and I'm thinking 0.011, right? So I'm going to delete that. Then I'm going to type equal chi square. If I use chi-square dist, I need to put in a number on the number line. Well, I'm putting in a number on the number line, right? Now, notice that the right tail is highlighted, or the right tail is blue, right? This independence test is a right-tailed test, an upper-tailed test. So there's a special function here. If I hit back, I can click on chi-square.dist.rt. That .rt is associated with upper tail probabilities. So using chi-square.dist.rt, parenthesis, I'm going to click on the number line, because that's the input to this, a number on the number line, 6.3708. I'm going to do comma, and I'm going to click on degrees of freedom here, 1, and then hit enter. And I get a p-value that is close to what? So if I change this back to the test statistic, 6.371, right? My p-value, according to statdistributions.com, is 0.011. According to Excel, it's actually 0.0116. Because remember, this is rounded off, right? This is rounded off here. This is not as accurate, right? So my p-value is actually 0.0116, not 0.011, right? Now I want to get the critical value of the test. So remember, on the critical value, when you're finding the critical value, you plug in significance level. And I got a critical value of 3.838. So here I'm going to type equal chi-square. And I'm going to use inverse instead, but instead of using inverse, again, this independent test is a right tail test. So I'm going to click on chi-square.inverse.rt, RT meaning right tail, right? And then I'm going to click on the significance level, 5%, and then I'll click on the degrees of freedom, 1, and I'll hit enter. And it should be close to 3.838. To 4 decimal places, it is 3.415. So the statdistributions.com is off a little bit, right? So let's put the answers into our problem here. Okay, it looks like I did everything good, well, because the expected frequencies all check. The chi-square test statistic checks. So does the degrees of freedom, the p-value, and the chi-square critical value. Now for the conclusion of the test. Okay. Okay, so the significance level is 5%. So again, what I said is if the chi-square test statistic is under the white area, this white area is the non-significance area. This blue area is the significance area. So the test statistics on this side of the critical value, under the white area, the collective differences are insignificant. But if the chi-square test statistic is out here, under the shaded blue area corresponding to the significance level, then the differences are significant. And our test statistic is right about here, right under the significance level. So these differences between the expected frequency and the observed frequency, those differences are significant. And so the null hypothesis, going back here, this is the do not reject region, and this is the reject the null region. We're rejecting the null here because we have differences, and differences imply dependency. Here we have an insignificant difference, and insignificant difference implies independence. So this is the reject the null region, and we are definitely in the reject the null region. So our conclusion of the test is we reject the null hypothesis. When you reject the null hypothesis, you can accept the alternative hypothesis. And the alternative hypothesis is hired and race are dependent. Being hired depends on race, right? We can say that. Now, here's why. This is why this is not necessarily a discrimination test. The reason why it's not a discrimination test is because when you look at, you could have a situation where the expected frequency of white was greater than or you could have a situation here where, which is our case, the expected frequency of white is less than what we observe in terms of white and hired. And then when you look at the expected frequency of black and hired, it is greater than black and hired, the observed frequency. So here we conclude there's a dependency, but what's going on here is blacks are hired at a higher rate than our whites because their expected frequencies are greater than the expected than their observed frequencies. Sorry, I got that backwards. We expect, if we have independence, we expect 37, right? We expect 37.2963 black and hired applicants. Sorry, we only get 30. So what we observe is less than what we expect. So here it could be the case that black workers or applicants are being discriminated against. But it could be the case where this number is bigger than that, and this number is less than that. So the test doesn't automatically tell you that there's discrimination against black applicants. In this situation, because if the null hypothesis is true, given these totals and these totals, we expect 37.2963 black applicants to be hired, but only 30 get hired. So it looks like there might be some discrimination here. We have to, dig in a little deeper. Maybe the reason why this is because maybe in this particular community, black high school students mostly go to the urban inner city school, which isn't very good. And most of the white students, like in Baltimore, for example, most of the white students go to suburban schools that tend to be better and have to face the competition of maybe a private school, right? Which would make the public school more responsive to the teachers and the students. If that's the case, then maybe institutional racism, the institutional racism of the black students being in poorly performing public schools and white students being in above average public schools, maybe that institutional racism is the cause for these differences, these significant differences. All right. Okay, so in English, what does that mean? Oh, yeah, we already said that, right? Being hired depends on race. So let's hit enter here. And it looks like we got 100% on that one. Okay.